So coming to the electrostatics, the first question is, so ring is there here, whose radius they have provided to us. So, and the gap, the length of this particular gap they have given to us. So, which is the gap value is some 0 point or 2 pi into 10 to the power of. So, minus 4, so minus 3 like this. Okay, you can go for this one. Minus 4 conditions. So, pi also if I take it this one, or else if I leave the pi, then obviously this will come under to the 3. So, this is the one. The ring carries a charge of plus 1 coulomb. So, total charge that is been carried by the ring is going to be the 1 coulomb, the electric field at the center. Usually, if it is a complete ring, if it is a complete ring, then electric field at the center of the ring will be equal to the 0. So center will be equal to the 0. This is the basic thing. So that means we can say that the E, that is electric field of the remaining, plus electric field of the removed. So combinedly, it comes out to be the 0. So in the sense, the electric field of the remaining will be opposite to the electric field of the removed conditions. Now, if I go for an general conditions, that is the total charge, whatever the total charge is there. So the total charge is Q is been spread across the total length of 2 pi r. In the sense, 1 coulomb is spread across the length of the 2 pi r. Then for a length of 2 pi into 10 to the power of minus 3, then what should be the charge if I consider this as the dq conditions? Then we can find the charge of the removed portion. So that means dq can be written as it is q into, it is 2 pi r of, this will be the 2 pi into 10 to the power of minus 3. As we know this particular thing, this is the total charge is going to be the 1. And the radius value, if I substitute, then we'll be getting it as in 2 into 10 to the power of minus 3 coulombs. So this is the charge. So this is the charge of the removed portion. Removed portion. Okay. So now from this one, if I try to find out the electric field at the center, then it will be the 1 by 4 pi epsilon naught of, this will be the dq by square of the radius, that is going to be the r, and which is written as a 9 into 10 to the power of 9 into, this is 2 into 10 to the power of minus 3, which is your charge, and the radius value is going to be the 0.5 into whole 0.5 whole square. So on solving, you should be getting it as a 18 into that is 4, 18 4, so it will be 72, or it will be the 7.2 into 10 to the power of 7 Newton per coulomb. So this should be our option, sir. So that is your option B here. Next, coming to the other question here. It's as shown in the figure, the dust particle of the mass m is this. So there is a dust particle here of mass m, and the charge possessed by it, that is the 2 nanocoulombs here, starting from the rest, in the sense initial velocity u should be 0. Rest at the point A. So it is starting from the point A here, and it is moving in a straight line to the point B. So from A to B, it is traveling. He is asking what will be the speed when it reaches to this particular. So in moving so, there is no external force. That is the main important thing. So there is no external force is being acting. External force. That so since there is no external force, we can go for the law of conservation of energy. So at point A and as well as at point B. So what sort of an energy, that is kinetic energy plus potential energy at the point A, should be equal to the kinetic energy plus potential energy at the point B. Since initial velocity is equal to 0, kinetic energy at this particular location A will be 0. So that means kinetic energy at A is equal to 0 since initial velocity U is equal to 0, that is starting from rest. So now when I consider this particular thing, so we'll be substituting 0. Now there will be the potential energy over there. So potential energy will be so plus 1 by 4 pi epsilon naught, I'm writing K into this is 3 into 10 to the power of minus 9 nanocoulombs into Q naught by distance from this one to this one is 0.01. So here in the diagram we can see this is going to be in centimeters. I'm converting it into the meters here. Fine, sir. So this is the one. So next one, this is also 1 centimeter and this is also 1 centimeter. This is 3 nanocoulombs, 3 nanocoulombs. So let the charge, whatever is going to be moving over here is Q naught, that is 2 nanocoulombs. He has provided that. So let me also furnish that information over here. So it is 2 nanocoulombs, 2 into 10 to the power of minus 9 coulombs. We'll be substituting it later. So this is the potential energy between the left side charge and the Q naught. And next one, this is an potential energy between them. K into 3 into 10 to the power of minus 9 into Q naught by distance between the right side charge and the A is going to be the 0.02. This is at the A. So this should be equal to the final kinetic energy at the B, that is half mv square plus same thing. This is K of 3 into 10 to the power of minus 9 into Q naught, that is left side 3 nanocoulombs to the, when it reaches to the point B, the distance will be 0.02 minus K into, this is 3 into 10 to the power of minus 9 times of the Q naught by, it is 0.01. So next on solving, that is getting all these things to one side. So minus, if I bring it to this side, it will become plus. So that means if I take it as a common, that is K into, it is 3 into 10 to the power of minus 9. So these are the two things. So 2 also I'll include over here into Q naught is 2 into 10 to the power of minus 9 by denominator is 1 into 10 to the power of minus 2 minus 2 into this is K into 3 into 10 to the power of minus 9 into Q naught is 2 into 10 to the power of minus 9 by this distance is 2 into 10 to the power of minus 2 is equal to half into mass of the charge he has given 5 into 10 power minus 9, which is 5 into 10 to the power of minus 9 into V square. So now if I try to remove this one, so this is K value if I can substitute, or let's take the common thing over there. 10 to the power of minus 9 can be removed from these cases. So here 2 I can remove here. 10 to the power of minus 9, I'm cancelling on the either sides. So this is going to be the 5 is the 2. So let's take them afterwards. So this is going to be the 2 into K value. 9 into 10 to the power of plus 9 into 3 into 10 to the power of minus 9 into 2 by 10 to the power of minus 2 minus last one. It is again, this is K, which is 9 into 10 to the power of plus 9 into 3 into 10 to the power of minus 9 into 2 by, this is 10 to the power of minus 2 is equal to half into 5 into this is your V square. So on solving this one, obviously you can go for the solving this conditions. So from these two things, you can take it as an 9 3 is 27. So I can take the common as 27 into 10 square, which is in the denominator. And the leftover term is going to be, this is 4 minus 2 is equal to 1 by 2 into 10 to 5. Sorry, this is 5 into V square. So now this is going to be the 2 and this will be the 4. So 27 into 4 into 10 square, which is going to be the 100 by 5 is equal to your V square. So now on solving this one, you should be getting the V is equal to some 12 root 15, which is nearly equal to the 46 meter per second. So this is our basic thing. That means you will be option C. Now coming to our third question. So A, B, C is the capacitor condition. A, B, C, D are being here for conducting plates of the area and have the two consecutive plates separated by a distance of the d, the net energy is stored in this one. So energy stored in the capacitor, you can write it as an U is equal to half C effective into potential, that is V square. So that means we need to find out the C effective conditions. If you want to find out the C effective, the same circuit can be written as a, the circuit is simplified. So circuit is simplified as, so like this. So A is been given. So first I'll go for the plate A here, and opposite to the plate A there is a B. So this is B. So B is been opposite to the A as well as the C. So now I'll connect the B also here, and this is your C. I'm trying to write the independent capacitors over here. So from here, C is connected to the C is in opposite to the opposite plate for the D, and D is also as well as opposite to the E. So E is again, this is final value is going to be the F, and this system is connected across a battery over here that is been given in the circuit for us like this. So I'm not going for the key here. So this is the circuit. Now, according to the circuit, so A is connected to the C. So that means A should be connected to C. That means there are the two plates for the C. From the A, I have to connect it in between the both the plates so that both of them will be have the same potential. That means potential at this point and the potential at this point will be the same. Let me consider it as a V1. Now from the C, C is connected into the E. So this is again connected to the E here. So that means the potential at this point should also be same. So that means this is going to behave as a short circuit to the condition. So the charge, whatever is there, is going to be directly flowing in this way. And finally, the only one effective capacitance is going to be there. This is the only that will be existing. So in this case, there is no charge will be flowing through. No charge flows through or flows between A and C as well as between C and A. So only one capacitor will be available, only one capacitor is active. So which is the last one, that is E and F. So C effective is equal to C is equal to epsilon naught A by D. Let us substitute in the energy U is equal to half C value epsilon naught A by D into V square. Or if I rearrange this one, epsilon naught A V square by 2D. So this comes out to be our option as an epsilon naught V square by 2D denominator. So it should be the option C. So next one, sir. Charges Q1 and Q2 are lie inside and outside, respectively, of a closed surface. So there is a, imagine a closed surface is there like this. So there is an inside and outside charges are there. So one is a Q1. Let me take this as an Q2. Let E be the field. E is then field at the point, at any point on the surface. Pi is the flux and E is so flux over the electric field. Or he is asking what are the different conditions. So on what does E is going to be depend? E depends on what factors? depends on, that will be the Q1 and Q2. So similarly, but flux depends upon, phi depends on, uh, depends on only charge enclosed by that surface. This is the main important thing. So charge Q1 and Q2 is, Q1 is inside and Q2 is outside. So that means if I change Q1, that implies if Q1 is changed, E and phi will be affected, or will be changing, because inner charges are going to be changed. So that means A is going to be the true. So the Q2 is outside the surface. Only E will change and flux will not change since it is outside. Outer charges are going to be, do not affect the inner ones or anything. Next, in this case, if Q1 is equal to 0 and Q2 is not equal to 0, obviously then flux will be 0 and electric field will not be equal to 0. So this cannot be our option. So your answer is going to be the A, B, C. So next question of us is, in the circuit diagram shown in the figure. So all these three are in the parallel conditions. Suppose if I take the potential drops over here, so that means these three things, that is in the diagram or in the circuit, 1 microfarad, comma 2 microfarad, and 3 microfarad are parallel. Then what is an effective capacitance for the parallel conditions are C1 plus C2 plus C3, and that comes out to be the 1 plus 2 plus 3, so that is 6 microfarad. So if I reduce the circuit or if I simplify the circuit, I'll be getting this type of the circuit. So initially there is an 6 microfarad is there, and by combining 1, 2, and 3, you'll be getting it also as a 6 microfarad. And finally, also there is a 6 microfarad capacitor is there, and all of them are connected to an EMF of, this is 12 volts, which is being connected into the circuit. Now, since all 6 microfarad then C effective for all these things will be equal to the, that is 6 by 3, which is equal to the 2 microfarad. This is the final effective. So from this one, the net charge that is been flowing in the circuit can be written as n. It is C effective into applied potential difference, which is 2 into 10 to the power of minus 6 into 12. That comes out to be the 24 microcoulomb. This is your total charge or the net charge. So since 1, 2, and 3 are in parallel, so what are the different five subject questions he is asking? The charge on the 2 microfarad he is asking, 6 microfarad charge on each of them he is asking, then the potential. What is the, since all of them are in the series, charge on everyone should be the 24 microcoulombs. This is also 24 microcoulombs. So here also 24 microcoulombs, charge remains constant means, so charge on the 6 micro is 74. This is your wrong option. Now let's go for the first one. First, second, first, third, and the fourth options are being on this particular thing. So if I take this as an 1 microcoulomb here, and another one is going to be the 2 microcoulomb, which is parallel to the third microcoulomb. This is 2 microcoulombs. Another one is 3 microcoulombs, since all of them are parallel to each other. So this is the situation. So the total charge across all of them is 24 microcoulombs. So charge, this total charge, whatever is going to be the 24 microcoulombs, will be distributed in all of them as a Q1, Q2 and Q3. Finally, all these charges are going to be come out as an 24 again microcoulombs. So since potential is same, we can also find out the charge value. So now from this relation, charges Q1 is to Q2 is to Q3. We know that parallel condition potential is constant. So charge will be proportional to their capacitance. So that should be equal to the 1 is to 2 is to 3. So we need the charge Q1 in the first one. Q1 is equal to the one part out of this one. Out of the six parts, total charge is going to be the 24 microcoulombs. This will be equal to the 4 microcoulombs across the first capacitor. So this is the first one, 4 microcoulombs. So he has not asked that one. And potential across the first one. So potential across the first charge and all of them will be same. Potential is equal to Q1 into C1. Q1 is 4 microcoulombs into C1 is 1, that is 4 volts. So this is your option C, I think. So this is your option. We know, so option C is true, sir. We have got this one. Next one. So potential, all of them are the parallel. So here also it should be option D. Next, we need to go for the first one. So charge on this one, he's asking the Q2 is going to be how much? Q2 is two parts out of the total six parts into total charge is 24 microcoulombs. This goes for four times, that will be the 8 microcoulombs. This is C and D, both of them, and this is 8 microcoulombs is your option here. That means your answer should be the A, B, and D. Sorry, A, C, and D should be your option. Next, coming to the A, B, D. B is not there, sorry. So they should be C correct. Only I have written earlier. So this is the one. Next, three concentric spherical shells are there, A, B, C, D. Of the radii R1, that is R. Okay, so here it is been given as an R. Let me change this as an capital R, 2R and 4R respectively. A and C are short circuited. BE is being uniformly charged. So what is the main condition? Since A and C are connected, so what should happen, sir? Potential across A or potential of the A should be equal to the potential of C. So since he has given an charge of plus Q to this one, so since he has given a charge of plus Q to the B, then what sort of a charges? Let us consider the charge on this one is going to be the Q1 and charge on this one is going to be the Q2. So let me write that particular information. So let us consider, let the charge on A and C is Q1 and let me consider it as an Q2. But from law of conservation of charge, law of conservation of the charge, the total charge should be initially the charge on the A and C is zero. So final charge should also be zero, which implies Q1 is equal to minus of Q2. This is the relation we have got between the Q1 and Q2. Now coming to this one, circuits. So since A and B are these things, so now I'm going for the potential at A. Potential at A is caused because of the all the three shells. So that means VA can be written as antis 1 by 4 pi epsilon naught. First I go for the inner one, that is A only at a distance of R, plus second potential is because of the B, which is having a positive charge and it is at a distance of 2R. Third one. So this one is be the plus 1 by 4 pi epsilon naught. Charge on that one is Q2 and which is at a distance of 4R. Now if we take the common in this case and solve this. If I take the common, that is 1 by 4 pi epsilon naught. into R also, if I take it outside, then this will be the Q1 plus Q by 2 plus this is Q2 by 4. So this is our first information we have got. So this potential, according to the statement that we have written, potential of the A should be equal to the potential of the C. So let me go for the potential of the C now. So what is that potential of the C? Potential of C or potential at C, sorry. So potential at C outside one. So that will be written as an, we can go for that as an VC is equal to 1 by 4 pi epsilon naught. Because of the A, that is an inner shell Q1, it is at a distance of same thing 4R plus. So this is equal to the 1 by 4 pi epsilon naught. Since the C is outside the B also, you can go for the Q by 4R plus 1 by 4 pi epsilon naught. This is equal to the Q2 by 4R. As we know that potential across A is equal to potential across C. So the last term, if I compare, the last term will be cancelled here, or else I'll write it in this way, that is Q1 by R plus, I'm eliminating 1 by 4 pi epsilon naught, it is Q by 2R plus Q2 by 4R for the A, and this is equal to the Q1 by 4R, this is on the C, plus this is Q2 by 4R. What is the Q2 value? Is Q only. So that means this is Q by small 4R plus outside charges Q2 by 4R. So when I remove these two things, we can determine the value of the small q1. Take the LCM denominator here, it will be the 2R, here is going to the 4R. Take the 2 on that will become as an 4 into Q1 plus 2 into capital Q. This should be equal to the Q1 plus Q. So from this relationship, you can go for that is 3Q1 is equal to minus of capital Q. That means Q1 value is equal to minus Q by 3. This is your basic information. So since this he has asked the same question here, charge on the conductor A, in the sense we have considered it as an Q1. So Q1 value we have got it as a minus Q by 3. So your option will be the B. Next, coming to the seventh one, it's a paragraph question continued by the second question itself. Everything is going to be same, but here he is asking the potential of the. Substitute the Q1 and Q2 values. Whatever we have determined, that is Q1 is equal to how much we have got here, sir? Minus Q by 3. And Q2 is equal to, what is the Q2 is equal to minus of Q1. So minus of minus will be cancelled. So Q2 is equal to Q by 3. So this is our information. From this one, VA value is what, sir? VA value is equal to 1 by 4 pi epsilon naught will be common. Next, Q1, what will happen? What is the value of the Q1 is? Minus Q by 3 by R plus capital Q by 2R plus Q2 value plus Q by 3 by 4R. So this is the basic information. Now try to solve them. Take the LCM and go for it. So if I go for the LCM, this will be the 1 by 4 pi epsilon naught into R. And this value will be equal to the minus 4Q plus 6Q plus Q by overall divided by the 12. This will be the case. So if I substitute these things, so what will happen here? This is equal to the 1 by 4 pi epsilon naught into. So 2Q, this will be the 3Q by 12. This goes for 4 times. And your final answer will be the Q by 4 into 4, 16 pi epsilon naught. This is the basic thing. So what is this? Where is 16 pi? So this should be your answer. Next one. The ring of radius R and the charge plus Q is distributed uniformly over it. So there is a ring, sir. On this one, there is a negative charge which is being given. distributed, and you are placing another small q charge placed at the center of the ring, such that electric field becomes zero at a point on the axis where distance is going to be. He is asking the q in terms of the q by 4 into root n he is asking. Suppose if I consider this to be a ring. So consider this as a ring, and this is the axis which is passing through the ring at a particular distance called as an your radius, and this is also your radius. So now at this particular instant, what is happening at the center? You have placed a plus q, and on the ring you are having a minus q. So because the net electric field at this point becoming zero, this is because of the electric field because of the negative acting in this direction, electric field because of the positive charge is in the other direction. Since the net electric field is zero, you can take it as an E minus is equal to E plus. So this is because of the one is the negative charge, another one because of the positive charge. The E plus or E minus indicates the same thing. What is E? E is nothing but an electric field. So this is the one. Now substitute the values, sir. E1 is equal to Et. So 1, I'll go for an E because of the ring. So electric field because of the ring, if I want to go for this, is equal to, along the axis, kq into x by, this is r square plus x square whole to the power of 3 by. So your radius x value is also r. So that means kqr by r square plus r square. This will be the 2r square whole power 3 by 2. Or from this one, kqr by, so 2 cube is 8 and r square, that will be cancelled. That so this should come out to be the 2 root 2 into this is radius. So these two can be removed here. So sorry, one is the to the power of 3 by 2, 2 cancels here, it will be the cube set. So if I remove this, will be coming out to be the square. Now put down the values, sir, here. So that means k into capital Q by 2 root 2 into r square. This is the one. Okay, this is acting in which direction? Towards center. Next, energy stored in an or energy due to the external charge. So what is the formula for the external charge is kq by r square in a general formula. I'm writing this one. So k into small q by r square, if this is been provided. So now this is will be acting away from center. So now these two are in the opposite. So net, since net electric field is equal to 0, E ring minus E or E ring minus E of the charge, both of them should be equal. What is the value of the ring is, which is kq by 2 root 2 r is equal to kq by r square. So these two are being removed, please. So now he is asking what are the different conditions. So now what is the charge that might be flowing here? This is small q, sorry. So now only k will be cancelled here, sir. So here k will also present. You can remove the k itself. It is a small q and 2 root 2 into capital R, and this will be your 2 by, yes, this is something by, or charge q by r square. So if I solve this one, small q will be equal to the r square in the sense, small q is equal to capital Q by 2 root 2. So this can be readjusted as a q into 4 into root 2. Okay, so that is 4 can be written as an 4, 2 into 2. One of the root 2 can be, I will be getting the same information. Okay, so what he has asked in the question, please go through them. Find the value of the n. Where is the value of the n is there? These are the questions, sir. Find the value of the n value. He needs to ask those things. Now coming to the capacitor C1. So C1 is one of the capacitor maintained at the maximum voltage of the V1. That means from the charge Q1 can be written as in C1 V1 So which is equal to the 1 into 10 to the power of minus 6 into 6 kilovolts, 6 into 10 power 3, which comes out to be the 6 into 10 to the power of minus 6. So this is, sorry, minus 3. This is the information regarding the charge, minus 3 coulombs. Next, similarly, coming out to the Q2, which is equal to the C2V2, and that is 2 into 10 to the power of minus 6 into next one V2, so that is 4 kilovolts, 4 into 10 to the power of 3. So that is equal to the 8 into 10 to the power of minus 2, or which can also be written as an 8 into 100 coulombs kilowatt. So in this way, you can have this relationship, sir. So in this case, we are clear that is C1 V1 is less than the C2 V2. So that means charge is going to be tending towards the maximum. So C effective values are going to be the, what is the value of the C effect? Sorry, C effective is equal to C1 C2 by they are connected in the series of C1 plus C2. So which comes out to be the 1 into 2 by 3, which is equal to the 2 by 3. So this is an effective thing. From this one, maximum potential drop will be obtained from the maximum charge. So what is your maximum charge is there, or maximum charge by C effective. The maximum charge or whatever it may be Q1 by root over, uh, oh sorry, this will be Q1 by this nothing but C effective conditions we need to go for this. So this is the C by Q1 by first one. By what is the value of the C effective, sir? Here we do have C effective is 2 by 3. So that is 2 by 3. Since C effective is equal to 2 by 3, substitute them. So I'll be expanding this one, sir. Or else we'll be writing in another way. Q1 can be written as in C1 V1 by, so the fractional that is C1 C2 by C1 plus C2. This is only the effective case for a parallel condition kadra. So in the logic you got C1 C1 just the V maximum can be written as an V1 of C1 C2 by C2. So now when I substitute the value 6 into 10 to the power of 3 into 3 into 10 to the power of minus 6 by V1, what is the value of the V1 and everything? This is 2 into 10 to the power of minus 6. So on solving this one, you should be getting it as a 9 into 10 to the power of 3 volts, or else 9 kilo ohms, right? So this is the maximum potential that it can withdraw over here. It's a single answer question, no problems. So last one, the figure shows a concentric spherical shell. This has been Earth. In the sense, potential of the second one, which is equal to the 0. So V2, that is an inertial, or VB, since it has been connected to the Earth. Since VB is equal to 0, or else let me write here VB is equal to 0 joules. This is the fixed value. So since VB is equal to 0, on what factors they will be coming? So KQ by R or 2R plus K into minus Q plus R by how much, sir? This one is, this is also 2R plus K into 2R into H is equal to. So this value should be equal to the 0. So since this is an equation for the potential, because of the potential is for 0 conditions. So let me write it afterwards. Now let us go for the solving here. So which is equal to the KQ by 2R is 2R plus, since it has been not there, it is going to be the K into 2Q by, so denominator is 3R, the radius he wants to go, where the x is equal, when you compare this one, x is equal to 4Q by 3 is this. So this is the value of the charge, or the x value that I am going to take the extra charge is been adding over there. So from that one, we can get the Q2 is equal to minus 4 by 3Q, and Q3 is equal to minus x, which is equal to the 4 by 3 into charge. So similarly, Q4 it can be written as a 2Q minus 2Q plus X. Next, 2 into Q is equal to 4 by 3. So 4 by 3 Q. And the last one, 4 by 3 Q, it's a minus sign, and this also comes out of a 3 by 2 times of the alpha. So from this one, Q4 also you can derive 2Q plus X. So which is coming out to be the 24. Oh, sorry. It is only the 2Q plus the 2Q plus X. So we need the value of the X value already we have got over there, sir. So it will be the minus of 4Q by 3. That comes out to be the 2/3 of the qubit. So when you equate this one, that is, one should be related to whom the Q1 value. The value of the Q1 we have got it as an and Q2 value 4 by 3. So Q2 value will be equal to the 4 by 3. That means second one is dedicated to the minus 4 by 3 dedicated to this one. So next one. So one is going to be that is value of the Q1. Value of the Q1 should be equal to the entire world. Next Q3. What is the value of the Q3 that we have got here, sir? Q3 is equal to plus 4Q by this one. So this is your information. So one is C. So only one option is there. That is 1C. Sorry, 1D. 2C. That is third one is coming out to be the B. And the fourth one is, so this has been related to the A. So 1D. What is 1D? This is on 2C. 3, this one, 4, 1 should be A. So fourth is only in this possibility is there. So 2 should be greater than B. These were the relations given at that particular instances. So that means this should be our right answer.